In Unit 3, we're going to spend time talking about our triangle congruency proofs, and Lesson 1 talks about our first one, which is side, side, side. The first question wants us to identify the missing set of corresponding sides that we would need to be congruent in order to use our side, side, side congruence. So we're only talking about sides in this piece, not any angles, and then we'll state the congruency statement that relates our triangles. So the first one, obviously, they gave us two of our congruent sides. So therefore, there's only one set left that would need to be congruent, and that would be that side CB is congruent to side FE. If we want to state our congruency statement for our triangles, we want to make sure that we are matching up our letters correctly with how they correspond. You can pick your first triangle to be however you want. So A to B to C is how I chose to go. So now for the second triangle, I have to figure out, well, if A is between one congruency slash and 2, I have to find the one that is between 1 and 2 in the second triangle, which would be letter D. I then went to B, which was between 2 and 3. So between 2 and 3 in the second triangle is letter E. And then obviously that leaves letter F as our last one for our third letter. In number 2, this is where we're actually going to start to do some of our proofs. So we are given AB is congruent to CD and BC is congruent to AD. So I'm going to begin by setting up my chart. So the left side of our chart is always our statements, and the right side is always our reasons. Statement and reason. And it's really important that we start to get to know the vocabulary that goes with our first couple definitions. The first step is always our givens. AB is congruent to CD, and BC is congruent to AD. So both of those were given to us, so that's going to be our reason. Now, I always like to look at my givens first. Both of them are side congruency statements. So all we have to do is we mark them, and we move on. Now, it does not matter which one gets 1 slash and which one gets 2. Just make sure that they match up with their corresponding ones. So now we're out of givens, but I only have 2 sides congruent. Our only options are reflexive and vertical angles. Well, we don't have anything here with vertical angles, so that leaves us with our reflexive side, which is BD. So BD is congruent to BD. And the reason for that straight off of our chart is going to be the reflexive property of congruence. So now I look, in my picture I have side, 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 and then I have side, side, side on my other one, because what I just wrote down there was my third of my corresponding sides congruent. So once I have my pattern, I go down to my proof statement, which is triangle ABD. We want to make sure we copy it exactly how it's written, is congruent to triangle CDB, and our reason is going to be side, side, side. As we start to establish more of our patterns, then we'll need to be a little bit more careful about what our pattern is. But for now, since we only have the one, we know that's going to be our answer. In our third one, another proof, they've made this one a little bit harder or a little bit more challenging by giving us a midpoint definition to work with. But we're going to begin our proof in the same exact way. We're going to go statement, reason, and we'll always begin by listing our givens. So Q is the midpoint of MN, and NP is congruent to MP. So there are 2 givens that we had. This one is our easy one. NP is congruent to MP. So we're just going to mark those and we're going to move on here. The next part we want to work with is our midpoint. If Q is the midpoint of MN, that's going to tell us that we have MQ is going to be congruent to QN. And the reason for that, and if we remember what a midpoint does, is a midpoint divides a segment into two congruent segments. So there's going to be our second side. Now we're at a givens, but we only have two sides, so therefore we have to go to our rule, which is reflexive or vertical. And the only thing we have here is we have a reflexive side of QP. So QP is congruent to QP, reflexive property of congruence. There's our third side. So once we have three sides established, we can go to our proof statement. Triangle PNQ is congruent to triangle PMQ. And our reason is going to be side, side, side. And that's going to be all that we need for our first lesson on side, side, side proofs.